Hi, I'm Colin from the Ohio State University's Noble Gas Laboratory. In this video, I'm going to show you how we would collect a groundwater sample for dissolved gases using a copper tube and an Isoflask. Okay, to start, I'm going to show you what gear we need to collect our samples. Starting with the tools down at the bottom, we have adjustable wrenches, a 1/2 inch crescent wrench, and a 1/2 inch socket wrench. Then for gear, we need our 2 pairs of brass refrigeration clamps, 1 set of brass 3/8 inch swage lock nut and ferrule sets, and then 1 pair of 1/4 inch brass swage lock nut and ferrule set. Okay, I'm going to talk about the isoflasks toward the end, so for now I'm going to put it on the ground, and then I'll describe the actual copper tube setups. So in the middle here we have our 3/8 inch setup, which we would consider sort of our standard size for groundwater sampling. It consists of 2 lengths of 5/16 inch ID Tygon flexible tubing, 2 lengths of 3/8 inch OD stainless steel tubing attached to 2 swage lock stainless steel plug valves, and then our copper tube in the middle. At the top we have an identical setup, only in the 1/4 inch size, which the Tygon tubing is 3/16 inch ID connected to 2 lengths of stainless steel 1/4 inch OD tubing, 2 swage lock valves, and our 1/4 inch OD copper tubing. So the sampling port at a groundwater well may vary. For this demonstration I'm going to use a standard 3/4 inch faucet connection, which these parts are pretty common. You can get them at most hardware stores. So we have the faucet connection attached to a barb adapter, which is what we use to attach to our Tygon tubing. This is what the 1/4 inch connection will look like, and then our 3/8 inch connection. If you want to be extra secure, you can then also tighten hose clamps around the barb just to make sure the Tygon is snug. If you run into the problem where you may need different size tubing, you can also buy adapters, reducing adapters like I've shown here. As we transition into attaching the copper tubes to the valve sets, I'm going to zoom in on the nut and ferrule sets so we get an idea of how they should be oriented, because it's very important that the ferrules are oriented in the proper direction. That way you get a good seal on the valve. So to start with the 3/8 inch set, we take off the cap, and inside are the front and back ferrule. The front is the conical piece, and the back is the thinner piece with the lip, where the wider part is the bottom. With the 1/4 inch ferrule, we do not have a cap because these are not actually our standard piece. They also have a front and back set, but they're a little bit more pronounced. The front again is the conical piece, the back is the thinner piece, where the wider end is considered the bottom. And I'm going to show you real quick what they would look like as you put them on the copper tube so you can attach them to the swage lock valve. So this is the orientation for the 1/4 inch copper tube, and then for the 3/8 inch, will also look similar. And then using adjustable wrenches, you will attach these to the valve fittings, and what you want to make sure is that after you're done wrenching them, that the copper tube cannot rotate. That will give you a good indication that it is a snug fit. So I've gone ahead and attached the copper tubes to the valve setups for both the 1/4 inch and 3/8 inch copper tubes, and now we are ready to begin our sampling procedure. At each groundwater well, the first thing we need to do is purge the well. That way when we collect our sample, we know we are getting a representative sample from the current aquifer conditions. So during the purging, what we do traditionally is monitor the aquifer conditions using a multi-parameter probe, or for example YSI probe, and we monitor for electrical conductivity, temperature, and pH until those values stabilize. Once the values have stabilized, we are ready to actually collect our sample. So once we attach the copper tube setup and start flowing water through, The second important thing is to make sure we flush enough water to adequately purge the air that is currently in our setup. So our standard volume is at least 50 volumes of water through our entire setup prior to sample collection. Now, because the Tygon length can vary depending on need or what's available, just a reminder, the inner diameter of the 1/4 inch Tygon tube setup is 3/16 of an inch, while the inner diameter of the 3/8 inch setup Tygon tubing is 5/16 of an inch. That's with a 16 inch 3/8 inch OD copper tube where the inner diameter is 0.25 inches, and then a 16 inch 1/4 inch OD copper tube where the inner diameter is 5/32 of an inch. So because we don't have a water well that we can sample within the laboratory, I'm going to simulate the sample collection using a plexiglass tank filled with water that has a faucet connection. Now, the sampling method for the 3/8 inch copper tube and the 1/4 inch copper tube setup are identical, but I will show you both. So when I open up the water and let it flow through the copper tube until it's fully purging, as you can see, there are two things that we want to do during this time. The first is to slightly elevate the copper tube setup and gently tap with a wrench or another hard object, basically to release any gas bubbles that are stuck on the inner walls of the copper tubing. That way we don't have air contaminating our sample. And the second thing we need to do is exercise the valves. This is to release any air that's actually contained in the valve itself. That way we don't have air contamination in our sample. When we do this, we want to exercise the downstream end first. You open and close a couple times, let water flow through after. And then when we want to exercise the upstream end, we close the downstream end prior to this, and then exercise the valve a couple times on the upstream end. This way we don't actually let air basically migrate back up into the Tygon tubing. So as water continues to purge, I will do one more short round of tapping the metal, and our sample is ready to be collected. So when we actually collect our sample, it's really important that you close the downstream end first, then the upstream end, and from there we are able to detach our sample and then put on the clamps to safely secure and store afterwards. So for the 1/4 inch copper tube sample, although the method is identical to the 3/8 inch, I'm going to show you from start to finish how I would take the sample at a well. The first thing, we're going to assume that the well has been purged, and what I didn't mention earlier, it's really important that your sampling port comes before any filtration or pressurized tanks. That way, for dissolved gas purposes, you're not actually fractionating potentially the gas contents. So I've attached the faucet connection and opened the water. The water has slowly started to flow through. You can see here with the bubbles being flushed out. And now, although slowly, it is being purged of air. So during this time, I will tap the copper tube while it's in an inclined position. Try to release any more bubbles. I will exercise the valves, starting with the downstream end first. And then I will close that and do the upstream end. We'll flow through some more. One more round of tapping. And then finally we're ready to collect our sample. So downstream end close, upstream end close, and our sample is ready to be detached. Okay, now we've collected our samples in the copper tubes and we're ready to attach the brass clamps. Before we do that though, I want to make sure that I point out we do not want to reopen either of these valve sets prior to putting on the brass clamps, or we may accidentally lose our sample. Okay, to start with the clamps, we remove the nuts and washers from the bolts. and then we position the bottom block of the clamp about an inch from the end of the copper tube. That way, when we actually tighten the clamp, we do not damage the end connection, which would make it difficult to reconnect the sample to our vacuum system when it comes time for analysis. And then the second thing we want to do is make sure that we are basically perpendicular to the copper tube itself, and then the copper tube is aligned in the middle of the actual crimping portion of the block here. And I'll reattach the top block, reapply the washers and nuts, and to start you can finger tight, and at this point it should be relatively secure, and from here we will use the wrenches to tighten fully. So what I'm going to do is the same process with the 3/8 inch copper tube. Again, about an inch centered over the copper tube, and then finger tight nuts. From here, we will use the 1/2 inch crescent wrench and the 1/2 inch socket wrench to fully tighten our clamps. Now, the crescent wrench we use as a stabilizer by putting it against the sidewall of the top block or bottom. And then what we want to do with the socket wrench is alternate every few rotations between the two bolts. That way, when the crimp is lowered, it drops evenly and you get an even clamp. So every few rotations, switch. I jumped ahead and put the remaining clamps on the two copper tubes. And I want to point out, if we look at the side, the side walls of these blocks are either very close or touching, and based on the gap in the clamp itself and the wall thickness of these copper tubes, we know those are reliable crimps. And from here, we are ready to detach our copper tubes from the valves, as we have now secured our sample within the copper tubes. Okay, I've detached the copper tubes from the valve setups using the adjustable wrenches. And the final step in this sample collection process is to put on the end caps if you have them, which we do for the 3/8 inch copper tube. Prior to putting on the end caps, we want to fill these sections of the copper tube on the outside of the clamps with water as an added layer of security, and then we tighten the caps on with the adjustable wrenches. And so after we've put on the caps, these are our completed groundwater samples in copper tubes that are ready to be labeled. Okay, so the last portion of this video will be describing how to collect a water sample using an Isoflask developed by Isotech. It's their proprietary sampling vessel. Inside, they come with instructions, a sampling tube with a faucet adapter, and the Isoflask itself, which is vacuumed prior to the sampling, and then also contain a biocide tablet. So I'd like to point out that not every box for the Isoflasks will contain a sampling tube, but they will contain the flask itself. And then, just like the copper tubes, when we connect this to the faucet setup, we want to purge just like we would the sampling apparatus of the copper tube. So I've attached the Isoflask sampling tube to the tank, and I've opened the water to let it start flowing. And you can see it's flowing out the end here. And the sampling tubes have their own shutoff valve towards the end. And we want this to purge similar to our copper tube setups. And then when we're actually ready to attach the Isoflask, we do so while the water is flowing through. So Isotech recommends for their Isoflasks that you fill it to 600 to 700 cc's of sample, which should have a thickness of about 2 inches. So I'm going to let the water flow through once more, and then we will collect our sample. So the first thing I'm going to do is fill the top of the Isoflask nozzle with water. That way we don't introduce any air that would then contaminate the dissolved gases in our sample. And then while it's flowing, I push down on the nozzle, and although it's slow, it starts to fill. And we'll jump ahead when this has reached the appropriate volume. So, as you can see, this is our filled isoflask. It's about 2 inches across. Look, I've closed it off using the shutoff valve, and we just pull out, and we can send this to Isotech itself, who will do the analysis.